it's a good oh, later.
Okay, it is now recording. Oh, and I lost my background. Let's see. Well, it's blurred. I guess that's good enough for now. Well, welcome to the introduction to computer-aided design, the first phase of 3D printing. And we'll go ahead and share my screen. We'll go to Safari. And here we are. So I've just logged into my OnShape account. And you've already, I think most of you had a chance to create a free OnShape account. It's free for students and teachers. And you may, since I know this is a homeschool audience, you may have to say I'm at a school. I don't know if it made you do that or not, but sometimes it says identify the school you're at in this town. And so feel free to choose the sending school, and so
I just made stuff up. Does that matter?
I'm sorry?
I just kind of made stuff up. Does that matter? Like
No.
I put in Miller Homeschool and I didn't select anything that was
No,
there. Will that be a problem?
not a problem.
Okay.
No, no. If it gave you an account, it's not a problem.
Okay. I have an account. So
Good.
it was a little bit of a challenge, which is why I was late, but I think
Well,
I got it figured out.
it's not an issue. So, if you guys can see my screen, then you're seeing the Onshape.
Yep.
Great. So if I hit this button over here called Create, and then the first thing I'm going to create is called Document. So don't click by click with me. It's not necessary. I'm going to give you a bite-sized chunk and just introduce this to you, and then I'll let you make something. So I'm going to create some object. I'm going to call this your basic cube. And then this is the environment that you'll be in. And so the first thing you might notice is that there's these three, they're called planes. Okay, so there's the front work plane, which would be like your screen in front of you. There's the top work plane. In some other programs, it's called the base, but that's like your tabletop. And then there's one called right, which is going right straight through me. And so in order to create a 3D object, in this case, we're going to learn how to create a cube. You have to choose a work plane. For this simple particular object we're making, it doesn't really matter. Okay, so I'm going to click on top, and you can see that that top work plane is selected. I could choose the front or, the side. And over here, okay, under the features, you can see that these are where you can also select the work plane. So I could click here, or I can click on the surface of that three-dimensional plane. Then I'm going to go to my toolbar. If you look at the toolbar right now, it has features. Features are extrude, revolve, sweep, loft, thicken. Then there are these sort of sub features that you can do to an already existing three-dimensional object, like I can fillet, I can chamfer, I can draft, I can rib, I can shell, put holes. So I can do things to three-dimensional objects. So this first set of tools are the main features that let you take a two-dimensional profile or object and make it three-dimensional. These features right here are ones that let you take a three-dimensional object and then tweak it, like round the edges. So, or put holes through it or something. Something like what I did when I made this object right here is I put some holes in it after I made it. And then I'm going to click on the sketching tool. Now watch the toolbar will change. Now there's a whole different set of tools. And I'm sure that when you're first looking at this, it's very overwhelming. Like, oh my gosh, there's 17 little icons. I don't know what they do. Actually, most of these, if you ever used any computer drawing program, like Paint on your old Microsoft computer, you've seen line tool, square tool, circle tool. This is a three-point arc. There's different arcs. So some of these are nuanced. Like if I'm going to make a circle, I can make it from the center and click and drag. I can click in the center and then click somewhere else and make it and then drag. So there's a variety of ways to make it. There's an elliptical object. So anyway, they're just sort of sub features on that particular shape. Now, one thing I don't like about this particular program called OnShape is that it doesn't automatically rotate to the view that I would like to do for drawing. And so I've chosen that top work plane, which is kind of like your desktop. And so over here, this tool is very powerful. This object over here on the side allows me to rotate and move um, in my three-dimensional world. And so what I'm going to do is just click right in the word top, and it rotates the work plane so that it's facing me. So if I'm making a cube, what would be the two-dimensional sketch that would result in a cube?
Square.
A square. So I'm going to look at my tools. I have a line tool. I could make it 4 lines if I wanted, or it'd be a little faster, just choose the square tool. So now that's chosen. This thing in the middle, it's the same name you might call any Cartesian plane. So what do you call that spot in the middle?
Center. Or,
The origin.
oh,
So, but can you see how it's highlighting when I move near it? It is turning orange. That's going to allow me to click right on that. So if I get close to it, it clicks. Actually looks like I didn't click on it. Okay, let's go back to my square tool. That's weird. Okay, now I'm right on it. Okay, now I'm dragging around, and one thing that's really important, which I should have done before we started, is how big do we need the cube to be? So this cube right here, this is a 1-inch cube. Now, I do realize that in the United States, and there is one other small island country in the world that still use the imperial system that's based off the size of a king's shoe. Everyone else in the world uses the metric system. Every 3D printer you're going to run across is going to fundamentally be based off millimeters when they print objects. So I need you to start thinking now in millimeters. Okay, you can do inches, but when you send your files to the printer, if you're not careful, you're going to end up with objects that are infinitely small because you're like 1 inch is like it's going to think 1 millimeter. Okay, so rather than you know have that issue, start thinking right now in metric. So do you know how many millimeters are in an inch? 25.4. So it's 2.54 centimeters is an inch, or 25.4 millimeters, right? Because you just move the decimal. It's a lot easier than the metric system's all based on 10, right? So it's easy to move things around. So I'm going to make a 1-inch cube. So, but when I'm dragging this, I could try to really like look at those little numbers but I don't have to. Once I click once with my mouse, it highlights, and you can see that box in the bottom is now white. I can type in what I want, 25.4, and I can press return, and then it highlights the other box, which I can type 25.4, return, and I've now made a square, okay, as a 1-inch square. These little dimensions right here show you, the size of your object. Now, if perchance I screwed up, okay, so there's a back button over here in the far left corner. Okay, and I made a square and I clicked and I did not like those measurements. There is a measurement tool. It's called the dimension tool. Okay, and what I'll do is I click on the dimension tool and I can highlight that dimension. Okay, so if I click on that, I can go 25.4, enter. I can go down this one, 25.4. So now I've done the same thing. My only point in showing you that is that if you don't do the exact clicks I did, which is one click to start your square, then one click, then type the numbers, the dimensions that you want, you might have to go edit the size. But always, as a rule of thumb, design something that you know the size of it. Don't just sketch randomly. Okay. This is called dimensional analysis, and it's important that you begin the concept of what you want to make with the size of how big it's going to be. So I've done that. Now I'm going to go over here and get out of the sketching world. I've already made my two-dimensional object, so I click the green checkbox, and there is a square. Now there's some preset views And if you've ever seen an exploded like three-dimensional view, they might show you a top view, a side view, but they'll also show you what's called an isometric view. It's tilted. And so that's what you might see as a three-dimensional object. So if I just choose isometric, it kind of rotates it back to that the way we saw our planes before. But I can use a two-finger click and drag around as well. Okay. But if I get like all spun around, I can always go back here and click one of those views. It rotates us back. So getting familiar with this tool over here, so that you can orient yourself around and know where you are is very helpful. Now I want to take this into a cube, and so far it's just a flat dimensionless square, right? So I'm going to click on the square itself, and a little one has been created. It says you've chosen one object. Then I look over here at my features, and the most common feature used, most popular, most useful is called extrude. Have you guys heard the word extrude before? Do your kids ever have Play-Doh and they have the ice cream machine where they squish down like this and it shoots out like kind of a shape? My son had that. And so I could like put a triangle in and squish the Play-Doh through and it comes out in this triangle kind of shape. It extrudes out, or a square and it comes out in like a long cylinder or a long, uh, cubic shape, or a circle and it comes out in a cylinder. So um, another way to think about it is toothpaste. When you squirt toothpaste out, it comes out looking like a cylinder, right? Because the end of your toothpaste tube is round and you're squirting something out, you're squeezing it out. And that's what extrusion is. And so I'm going to go ahead and hit the extrude button. And it says, all right, we're going to extrude it out. And it's just going to guess. It doesn't really know what I want, but it's going to say, I think you want 25 millimeters. I'm going to say, I want 25.4 because I'm doing a 1-inch cube. And I could also drag this little arrow if I wanted a different dimension. Um, but I'm going to go ahead and just type in a number I want right here, and then I hit check. So that was it. What I'm trying to illustrate to you, and hopefully you're feeling like this, is I didn't know what CAD even stood for a few minutes ago, and now making a cube, apparently you just make a square and then hit extrude. That's it. And it should be pretty straightforward. So I'm going to go ahead and pause the recording and I'm going to let you guys try that, okay? Once I find there it is, pause. Oh, that's screen sharing's pause, not recording. Let's see. Okay, so everyone's made their cube. And a great question came up, which was when I first created my account, I'm still in inches by default, and we want to change that to millimeters because that's what the 3D printer wants. So on this little drop-down menu next to the name of my document, I can say workspace units, and that's where I want to change this from inches to millimeters, and then hit the green checkbox. Okay, that's going to make your lives so much easier when we export our files out for 3D printing. Now I'm going to go ahead and make another shape for us, another basic shape, and then you're going to try that, and you're going to get really good at doing this. So I'm going to click on the word OnShape. So no need to do anything, just watch. I promise it'll only be a few clicks. I'm going to repeat what we did last time, create a document. I'm going to call this one a cylinder, a basic. Okay, now I'm going to get into my workspace. And just like last time, I'm going to click on the top work plane. I'm going to rotate it around, click on the word sketch. This time I'm going to choose a circle because I'm making a cylinder, right? So the two-dimensional shape of a cylinder would be a circle. So the default circle is going to be a center point, which is fine. I'm going to go to the origin, click and drag. And if I click once, the dimension of that object has been highlighted, so I can type in what I want right now. I'm going to make a 1-inch cylinder. Now, from our previous discussion, 1 inch in metric is 25.4. And by the way, teaching metric is a important CSO that you have to cover anyhow. So I've made my circle. I'm going to say I like it. I click on the green checkbox. So I've made the circle. Now I want to see it become three-dimensional. So I'm going to use two fingers on my trackpad and rotate this around a little bit so I can see that circle. I'm going to click on the shape. Now, one thing you might accidentally do is click on the edge. We don't want the edge. In this case, we don't want to extrude just the edges out. I'm not making a hollow cylinder. I want to fill it in. So I'm going to click on the hole in the middle part there of the shape itself. I go to my features, and next to the word sketch, the first one, our most popular favorite one, is extrude. Click it, and it's going to assume, again, I don't know, what do you want, 25? I'm going to say no. I want to make this 25.4, a 1 inch tall cylinder. I press enter and green checkbox. So I have now made a 1 inch tall by 1 inch round cylinder. Okay. So I'm going to go ahead and okay, so we made a cylinder, and now what we're going to do is we're going to very easily adjust, how high it is. So I can just drag that little handle, or I can type in here in this box. So I'm going for the 25.4 millimeters. And this is where I'm also covering my metric to imperial conversions standard. So you know that's an inch. And the green checkbox always is the one that says, I like it. So here we have a cylinder. Now, this is a 3D printing workshop. So you're thinking, great, Todd, you showed me how to play around on some website making things, but how does that become a 3D object? How do I make this or this or whatever object I'm trying to make? And if I look down at my model tree, I see the word part. That refers to the entire three-dimensional part. Okay. Now I could have had all kinds of different shapes and features here that I did. I could have rounded the edges of it. But at this point, I made a cylinder. I want to make it, I want to print it out now. So I right click. I'm not sure if you're on Macs or PCs. For my Mac, I just do two-finger click. On a PC, you'd right click. And then I look at these menu options, rename, properties, export. So when I export this out, it's going to say, what do you want to export it out as? And it says, give me a name. I'm going to say it's a 25.4 millimeter cylinder. The format is STL. Okay, this is the PDF of the three-dimensional world. Okay, so if you're familiar with word processing, my analogy I've been using, and we're typing something in Microsoft Word, it's going to make a .doc, right? The little letters at the end define what kind of file it is. If I was using a different word processing tool, it might be RTF or some other rich text formatter. But in this case, STL is a three-dimensional object that can be opened by any 3D printing software. So we're exporting out in a very open format. It, in fact, is a bunch of little triangles when it does this. And so it says, let's see, format binary. I'm just going to leave it like binary units. And this is where if you are working in inches, always make sure you export in millimeters. And my strong advice is just work in millimeters. Okay, resolution fine. Now, if I'm making a cube and everything's triangles, then I have two triangles on the flat surface of my cube. And then the edge is a 90-degree sharp edge. So I don't need fine resolution on a cube, but on a cylinder, I have a round shape. And so I'm going to need lots of little triangles. So this resolution right here, okay, is going to define how many triangles are created when it exports this shape out. I should just always leave it in fine. Why would I care? And the answer is I'm certain you've probably taken digital pictures before, and you may have been like, "Whoa, look, I got like how many megapixels I can take, millions of pixels. When I'm pretty old. When I started taking digital photos, it was like low resolution, and the file sizes were also small. And as the cameras got better, the resolution got bigger and bigger, which is great for printing, but it meant the file sizes went from kilobytes to megabytes to, gigabytes. So the file size gets larger. So the only reason this matters is A, if you have round shapes, you really need to choose fine. But if you don't, you can choose, medium or coarse, if it's only 90-degree, shapes. But if you don't choose fine on a round object, it's going to have flat edges to it. So it'll look more like a stop sign than a circle. So I'm going to leave it on fine. It says I want to download it. That's what I want to do. I'll hit export. Allow. Okay. And boom, it just landed over here. Now I'm going to change my share a little bit here. I'm going to open up my slicing software. Now, the 3D printer that we loan out is called a MakerBot. It's a company. The printer I use most often nowadays is made by Prusa. But every 3D printer has its own software that does the slicing. And when I say slicing, it's going to break it up, your three-dimensional object, into layers. So I ran out of plastic last night. I hit print and left work, and I was making one of these ramps, and when it ran out of plastic, it just stopped. So if you look here, inside the middle of my object is this grid pattern. That's because it's not a solid plastic piece. It would be very slow and very expensive to print a solid plastic piece. You can say, no, 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 this has got to be really strong. I want solid, but generally you're going to choose what's called an infill. And the higher the value from, very little infill to completely solid object would change the honeycomb pattern that's inside of your object. So the software that does the slicing and then says to the printer, start at this spot, and then squirt plastic out, which is also called extrusion, by the way, funny enough, and then move left, and then squirt more plastic out, and then move right and squirt more plastic out, and that is the path that I'm going to take. So the 3D printer is kind of like a robot. And this is the code. It's called G code. That's going to be sent to the printer from the software. So I need to get an object in here. And so what we're going to do is we're going to add an object. Okay, so I'm going to click on this little project panel, add model, or I click on this big box right here. And it's going to say, great, here is your computer. I'm not sure if you can still see that, but there's a box that popped up that said, where's the file you want to print? 25.4 millimeter cylinder, open. And it's going to now import that and put it on the build plate. And this models my 3D printer right here. Okay, so there is the cylinder. By default, it should place it flat in the way that it thinks makes the most sense. If you can imagine, I could potentially, have this thing oriented in a different way, like this, right? So now my cylinder's on its side. Imagine that I wanted you to print a cylinder with your toothpaste tube. You're squirting toothpaste out, you're extruding it out, right? And I want you to print this object. Or maybe a better analogy would be a cake decorating, if you're squirting out frosting. I could squirt frosting in a circle and another circle and another circle and get higher and higher in my layers and make a cylinder. But if I wanted to print it sideways like this, I'd print one little edge and then I'd try to go up in midair. And it's just going to droop over and flop, right? It's not going to go up into an interesting shape like that. So like my this object right here, okay? If you look, there's a groove in the middle. I can print it with the bottom on the print tray, on the build plate, and the groove up in the air. If I were to choose upside down like this, the problem is how is it gonna wait to print in midair? And so it's gonna have to create what's called support material or a scaffolding. Okay, it would build plastic up and then it would be able to print on that surface. It's going to add time and cost, and then you have to break that stuff out. So if you can think when you're printing something, which orientation would make the most sense? This way, this way, this way, this way wouldn't work. I'd have to I can't print this top over here without the plastic, falling off. So it'd have to fill this entire gap. Does this make sense? And so when I'm printing the cylinder, I want to choose, okay, what orientation I print it at. So it says place face on build plate. So I click on that button. It says give me a face. There's a face of my object right there. Okay, and orient that down. So now and again, this was the default. It already brought it in, stuck it down like this already. I'm just trying to illustrate to you that when I bring something into a printer, I have to consider how it's going to print. Okay, so I have my object in here. We're done. We've already oriented it if we had to do that. There are other objects, other tools in here. So if I like clicked on the object and I did copy paste, I can make more of them. And I can click on this button here to arrange them. And so it'll arrange them in a way that it thinks makes the most sense. If I did something weird, I could say arrange the build plate, and it will arrange everything in a location that makes the most sense for the printer for speed and efficiency. At this point, I would go ahead and hit export, and I'm not plugged into the printer right now, and so it doesn't see it. But when I do that, it would go ahead and it would create the G code that talks to the printer. And that G code is what we're going to then send and print the object. I'm not plugged in, so it's going to save the G code. Just for fun, let me show you the other slicing software, just as kind of an analogy here. This is really quick. Okay, if I were to, for example, show you Prusa Slicer. This is not the printer that we loan out, but it is the one that I use most often. We have several of them here. Okay. But you'll notice that this software looks a lot like the other software, right? There is the build plate. Okay. And so there's a little button that says add object. Click on that. There's my cylinder. Click on that. It placed it in the middle. Again, this should all look exactly the same. But here's what's really neat. This software, when I hit slice, it gives me a really easy tool to go through and show you the layers that it's printing. So let me zoom in a little bit on the object. And this isn't quite as sexy on the MakerBot. This is neat for me to show you. Can you see the honeycomb pattern filling in right there? So it's showing you what would happen if I hit print. Exactly what layers. It tells you that's the perimeter, that's the external perimeter, that's the internal infill. So it's showing you all those different layers. And then eventually it's going to print the top on it. And it can show you the path that the printer is making. So this is over here, this bottom little slider shows you the actual print head moving around on that surface, which is neat. So this just helps, I think, students understand the translation between my three-dimensional object and the tool path, it's called, that my printer is going to make. So can you see the little print head moving around? And it's now printing more grid patterns, and it's printing around the edge of the circle. So that's what's going to actually happen. And I can look at different layers I want. So it's just neat that this particular slicing software allows me to kind of show you exactly what's happening. It kind of demystifies what's going on here a little bit. And at this point, I would just export my G code. It says, where do you want to save it? And that's now ready for me to put to the printer. Okay, so that's kind of the wrap up of we went from a shape, a circle or a square. We used a feature called extrude, We made it a three-dimensional object. We exported the three-dimensional object out as a STL, a stereolithography file, and that file can be opened by any slicing software. And that's the go-between between your head and that 3D printer is converting your three-dimensional object into a computer code called G code that is going to describe exactly where the print head goes, how much plastic it squirts, and how much infill to have and stuff like this. Okay, so that concludes our crash course part one on 3D printing. So do you have any questions that we want to include in the recording?
No, thank you. You did good.
Okay, so what we're going to do is